So here we are going to discuss number 1, part A. It talks about matching, and we're going to match the letters to the numbers. The letters on this column there match to the numbers on the right-hand corner. So for example, A, qualitative data, was matched to number 5, which is happy. Happy is a qualitative data. Data, remember, data is the specific value of the variable. So A matches to 5. B, stratification, which is a type of sampling technique. B was matched to 3 correctly. Stratification deals with the selection of a random sample from each group. So the population will be in groups, and from each of the groups, a random sample will be taken. So that is stratification. Part C, sorry. C is quantitative continuous data. Quantitative continuous data number 2 was matched to 2. C was matched to 2. 180 meters. 180 meters was collected by measuring with a measuring device. Once you have measured, you have obtained a quantitative continuous data. D was matched to number 1. D is observation. Observation is a type of mannerism of doing a research whereby you do not interfere with the study object. You simply collect the data. Measuring the height of trees does not interfere with the state of the tree. The tree remains the same. You just measure its height, so you are observing. D was matched to number 1. And E was matched to number 4. Qualitative variable. The variable is characteristic of the study object. E was matched to 4. Well, that's supposed to be mood, not mood. The mood is a variable. The mood of a person could be happy, sad, angry. So E was matched to 4. Mood is a qualitative variable because the data will be in widths. And here you have the qualitative data. Happy is a data, is a specific value of the variable mood. So E was matched to 4. Qualitative variable, an example is mood. Or the examples of qualitative variable will be color, etc. So we're still on number 1, part B. It says the topic is fundamental statistics, fundamentals of statistics, math 1-to-1. Students, fundamentals of statistics, math 1-to-1 students. The research question is, what is the average score of the population of math 1-to-1 students? And the hypothesis, which is the claim, a response to the research question without empirical evidence. Response by saying, well, the average score of the population of math 1-to-1 students is less than 76. Okay, let's say it's less than 76. So that's your opinion. So these hypotheses have to be tested to see whether or not it is true. So the objective now is to determine the average score of the population of math 1-to-1 students. So data has to be collected to try to refute or confirm, authenticate that hypothesis that was made about the population. A sample has to be used to do that. So as you can see, the data was collected, it was organized, and it is represented using a box and whiskers diagram. Now, if you take a close look at the box and whiskers diagram, as you can see, the lower end of the scale starts down here, 65, and it goes up to 95. So the minimum score appears to be 65, the maximum 95. The majority of the values appears to be between 90 and 80. The median is 85. 80 appears to be lower quartile and 90 the upper quartile. And this seems to be skewed to the left because the majority of the values are on the higher end of the scale, and the box wants to move to the left to be centralized. So this is skewed to the left towards the negative side, towards the left side, okay, the lower end of the scale, that's where the skewness is. So this seems to be skewed towards the left. Just by inspecting the box and whiskers, all this information can be deduced. So concerning the box plot, the first question said to state the median. So the median score, which is symbolized as Q2, is 85%. Now you can clearly see the median is 85%. Part 2 says to complete the pair of hypotheses. So we must first start with the claim. The claim says the average score of the population of MATH121 students is less than 76%. That's what the claim is saying. So this hypothesis, this claim has to be translated to symbolic form. So here's the symbol for less than, and because less than does not carry the equal sign, this is an alternative hypothesis because the less than symbol does not carry the equal sign. So here is the translation. Alternative hypothesis, the population mean is less than 75. So the null hypothesis now will be opposing the alternative hypothesis, and it must carry the equal sign. So the sign will be more than or equal to 75%. Well, 76 actually, not 75. Okay, we can just change this to 75. There's also a little typo. So the null will be saying the population mean is more than or equal to 75 because these are like two persons debating, they must oppose each other, but the rule is that null hypothesis must carry the equal sign. Always remember that. So the alternative is saying the mean is less than 75. The null is saying the mean is more than or equal to 75, and this will compare the pair. This will complete the pair of hypotheses. Now, part 3 is asking, should the null hypothesis be rejected? And the answer is no. Now, part 4 is asking, state a valid reason for your answer in part B. The answer was no, the null hypothesis should not be rejected. And why is that? Remember we said the median score, which is an average, is greater than 75%. That's what we got. Actually, we got the median to be 85%, which is true. 85 is greater than 75. And that is what the null is saying. The null is saying the mean is more than or equal to 75, more than 75. Okay, now the median is a mean. Okay, so therefore now the median is an average also. The mean is an average, the mean is an average. So if you get in an average of 75, of 85, that lines up with what the null is saying, that the mean is greater than equal to 75. So this statement cannot be rejected. Okay, so the null hypothesis must not be rejected for that reason. Another reason is that also the majority of the values are between 80% and 90%. Bear in mind, we got a lower quartile of 80 and an upper quartile of 90. So most of the values are between 80 and 90, which confirms that really and truly the mean appears to be more than 75. Okay, so this null hypothesis must not be rejected for that reason or reasons. Now, part 5 is saying to complete the conclusion. So since the null hypothesis was not rejected, which is saying that the mean is more than or equal to 75, this will be the conclusion. So here it is in words, translate back to words, from symbols back to words. The average score of the population of the MATH121 student is greater than or equal to 75. Or you can say in other words, there was not enough evidence to conclude that the mean was less than 75%. And that was a claim. Okay, so in other words, there was not enough evidence to conclude with the claim that the mean was less than 75%. Okay, that was what was claimed, but the evidence show an 85%. Most of the values are between 80 and 90. So therefore now there wasn't enough evidence to conclude with that claim. So we have to conclude with the null hypothesis, which is saying that the mean is more than or equal to 75%.